All right, thanks for that catch. But yeah, so kind of just want to get a poll from the audience. Were you guys able to attempt balance parentheses? Did you guys not get to it? Just kind of curious what the class thought about it.
Hey, Andrew and I went after it in like a pair programming sense on the Python side, and by the end of Friday, I think we were pretty close to a solid solution. I've been fiddling with it, but I haven't gotten to a point where I'm like, oh yeah, I've solidly got this, or at least efficiently.
Gotcha. No, I'm glad you took advantage of getting in pairs and pair programming. Again, it's something we don't mandate, I guess, every day of the week, but definitely nice to see that you guys are teaming up. So it's good to hear. Okay, any other thoughts on this problem, or you guys didn't get to it?
That when the challenge portion of it made it significantly more difficult, and so I wasn't happy with submitting anything until I could figure out the challenge portion.
Gotcha. Yeah, on that note, even if you don't solve a particular challenge, always get to just submit a pull request so that we can look at it. If we see students like kind of got hung up somewhere, we could focus more on it. Yeah, again, we're not grading them, so don't feel bad if you like attempted it but didn't get quite through it. Kind of just give it your best attempt, and even if you don't get a correct solution, still try to submit a pull request. Okay. So
I got a question, Ankur. Sorry. Is it okay if we commit working copies? So if we want to initially start it, we end up not having enough time to necessarily finish it, but doubling back and just kind of amending it later on. Can we do that as well?
Yeah. Again, so just to be transparent, we are not grading your challenges for every day. We are keeping an eye on it just to make sure people are attempting it and not blowing off the challenges completely. But at the end of the day, these challenges are for your benefit, as in to learn the material and to apply the material yourself. So, if you feel like you just don't want to do them, well, that's not going to be good for, I'm going to say you're going to struggle, especially because our assessments kind of mirror some of our challenges. So if you don't have that practice, our assessments are timed. So then you're going to struggle if you're trying to look up stuff at that point. But yeah, so again, for the most part, it's for your benefit. We've made it clear that you don't have to complete all the challenges every day. Kind of just do your best. If you get through them quickly, then great. Attempt them all. If you get stuck on a couple of them, just do your best to learn the material. That's the most important part, not to complete the challenges all the time. But yeah, glad you asked that question.
After Don blew up one of his GitHub things with an inadvertent git pull, I've started committing every chunk of code. I get to something that works. It's git commit -m. This is what it works, and then I go on, because that would suck if you're fully solved it and then lost it all. And I appreciate that pain.
Gotcha. Yeah, I remember.
That was helpful for you.
Yeah, I remember Don posted in the chat. He unfortunately lost some of his code due to Git troubles. So yeah, it's a good lesson in terms of incremental commits. If you complete a small chunk and feel like it works, kind of just commit it incrementally so that you have a save point. Either if you lose if you lose your work somehow, or if you break your code, you have some way to go back to it. Okay, so balance parentheses, I forked it. Next step is I'm going to clone it down to my machine. So I'm going to grab the URL here. And let's do a git clone. So that's git clone, and then the URL I just copied. Clone that down, just take a few seconds. All right, cool. I'm gonna cd into that directory. So it's called balance parentheses, and then I'm gonna open up a code window. So again, code, and then period for the current directory. All right, there we go. Let me move this over here. And I should definitely make my screen a little brighter. All right, so balance parentheses, again, we asked you to complete it in JavaScript and Python. I'm going to do it in Python just because we're going to be focusing on Python going forward. And I guess hint, not even a hint, but your assessment will be asked to be done in Python. So we're not going to, we're hoping you don't forget JavaScript, but Python's going to be your focus for the next couple of weeks. So I think it makes sense to do it in Python. So we have some test cases, definitely would like to have more, and then we'll code up our solution. So I'm actually just going to go to the challenge page because there was a bunch of test cases here. So I'm just going to copy these over, and then we'll talk about what our goal is here. So let me just wipe away all these. All right, looks like we have some naming differences. That's something we need to clean up. So Let me do a quick find replace. Okay, so we have, again, basic calls to our function, but we want to write some unit tests. So let's convert these. I guess these aren't even console logs. These are just calling our function. But I'm going to convert our output versus our expected output to test cases. So we're going to use the unit test framework from Python. So the first thing I'm going to do is import unit tests, because that is where we get all of our magic from. And then I'm going to add that statement that we've talked about. So basically, again, just to reiterate, when we do this, if name equals main, this is just checking if this is the main module that is running. Like I guess hypothetically, if some other modules, including balance, parens, spec, as a module, then this portion of the code would not run because this would not be the main module that is executing. So here we just need to call main. Again, this is just kind of starting up unit tests. I actually don't know the details of what main's doing. We could try to peek at the definition and see what's going on. All right. So main is calling test program. Again, there's a lot in here. I'm not going to go through it. But main does something. You just got to call it. But let's just keep it that simple. All right. So that kind of initializes it. And then let's get our test case class. So again, we're going to use this class keyword. And again, we're going to be going over this more in detail with our lecture, but set up some test cases. So let's call it balance parens test cases. We have to inherit from unit test case. Again, inheritance, another aspect of OOP that we'll talk about. Basically, this is granting all of our logic that we're going to use for testing. And we're extending it by adding our own test cases here. So let's create some test cases. So we got to create functions. To create a function within a class, we use the def keyword, which is the same if we're creating a function outside of a class. And then we have to name our test cases with test. If you fail to name it with test, like if I name it just something, the unit test framework is not going to identify this as a test case. So that is the one hang up in terms of naming. For unit test, to identify your function as a test case, you had to start with test. Underscore is not required. I can name this test something and it should work, but just follow the snake case of Python. I'm going to call it test underscore. And let's try to give these names. I might not name them all well, but let's look at the first one. So this one is test simple parens. One last note, make sure you include your self keyword. This is an automatic parameter that's passed in. So if you don't have that, you'll run into some issues. So we have self, and then we want to test this out. So let's do a self assert equals. All right, so the input of this should return the same output. So let's give that a run. All right, so very simple test case. We pass in opening and close parentheses, and we would expect our algorithm to return the same thing because those are balanced. Just back up a step in case we don't quite understand the problem. So balanced parentheses, we're basically trying to find opening parentheses and ensuring that we have appropriate closing parentheses. So if you go through these examples that we have listed on the challenge. So the first one hopefully kind of makes sense. We have an opening and a close one, so those are balanced. But let's look at one that's not balanced. So let's look at, I guess, yeah, example 2. We have a closing parentheses at the very end that is not matched up with the opening parentheses. So we have this parentheses before the B, but that one's matched up with the one after the B. And then we're kind of close, we're done with opening parentheses. So this extra closing parentheses does not have a buddy, opening buddy. So that one should be removed from the output. So if you notice the output here is lacking that extra parentheses at the end. So we're balanced here because we have equal opening and closing parentheses in that order. So we can't have closing parentheses before opening parentheses because that's not how parentheses are designed to work. So we look at an example like down here. the sixth example here, we have a closing parentheses before an opening parentheses. So in this case, the closing parentheses doesn't have a buddy that came before it, an opening parentheses buddy, so that one should be removed. And then this opening parentheses does not have a buddy coming after it that closes it. So in both these cases, these are extraneous, as in they're not balanced, so we remove them, and the output should be empty. Is everyone clear on what balanced parentheses is asking for? Okay. Continue on here. All right, so we wrote a simple test case. Let's write a couple more. So define, let's say, test extra closing parens will be my next test case. And here we're calling this one. And as our comment kind of tells us, we should expect this back as output. So output should match that. Okay, let's just do one more for now. We could add these after. Maybe I'll just add them now, but I won't name them super clever. Test is balanced.
Hardest part is coming up with names for these things.
I agree. I was just about to say that. I'm going to get lazy and probably stop naming them so particularly. I'm just going to start using numbers. Advanced. All right. That'll be my last named one. So let's do this quickly. Don't want to spend too much time on just writing test cases. All right. So we have output. And this is balanced. This is not balanced because I have an extra one. So and insert equals if we want them to be equal. Output should equal this. All right, so those are our named test cases. I'm just going to start getting lazy here. So test case 4. Got my column there. And okay, you guys get the idea here. We're just running a bunch of test cases. I don't know if I want to go through all of these right now because I want to get to coding, but again, good to have test cases so that we know what our target is. Okay, let's do some more here. Test case 5. Testing empty return. So I know I skipped one. I just want to make sure we cover all of our bases. So this one should return nothing. Output equals that. Actual output should be empty string. Okay, so we got half of these. Let's be happy with those for now. We'll add the other half, I guess, once we get our solution coded. But let's actually just see what our test cases run. So obviously all these probably should fail. This one would pass because I think, actually we're not returning anything. So
Anchor,
yep.
Are you allowed to have that in your, it's
Yeah,
only
no.
letters and numbers and underscores, correct,
Yep.
in Python names?
You got it. Yep, that was a typo. All right, let's give this a quick run. So we wrote our unit test cases. Let's bring up our console here. And we're in the Python folder, so make sure we're in the right folder. And let's just give it a run. So Python balance parens spec.py. All right, we ran 5 tests and we failed all of them. So we got a bunch of Fs here. Our goal is to change those into dots because dots means we pass them. Okay, so let's get to coding then. So let's put this down here, go to balance parentheses. All right, so right now we have a pass statement. So this pass statement just means this function has no real logic in it. Nothing's being done. None is the default return value, so none is being returned here from this function. Well, let's actually, try to pass all of our test cases. Again, so the first thing I like to do when tackling a challenge is to write some pseudocode because I like to have a game plan. I want to know how my code should be structured, what data structures I need to use, and kind of the overall look and feel of my function. So that's going to be the first thing I'm going to do here. So let's write some nice comments. Input, let's describe the input. So the input will be a string with, I believe the requirements said it's going to have only letters, numbers, and parentheses. So we don't have to worry about too many extra types of characters. So string with letters, numbers, or parens. And then return value should be a string. Balanced, of course. All right, so let's actually, all right, and the middle part is to balance our string. All right, so 3 general steps here. We're going to expand upon the middle part because that's our hardest part. But let me just start coding here. So we have our string. I know I'm going to want to create a new string object. As we talked about last week, strings are immutable. So I'm not going to be able to kind of update this in place. I could kind of keep rewriting to this value with a new string, but I'd rather keep my input untouched. So I'm going to create a new string. That's going to be my return string. So I'm going to call it balance. String will be my return string. That'll be an empty string for now. And then I know at the very end of my function, I'm going to want to return balanced string. Okay, so those were the 2 easiest parts. Obviously, the hardest part is going to be balancing our string. All right, so let's kind of think about this. What should this algorithm kind of do? Let's think about it again, just in like normal real world talk, and we'll convert it to code. When you're pseudocoding, you don't want to worry about anything that's code specific. So you don't want to necessarily go like, all right, I need to, write a for loop here, or like what data structure I'm going to use. For the most part, you just want to keep it generic in terms of overarching ideas here. So let's think about this. I'm going to need to go through my string, right? I'm going to have to investigate every character. So I'm just going to say loop through entire string. And then in that loop, I'm going to need to do a few things. So the easy case is if we get a letter or number, it's basically non-parens, because those are only 3 options, either letter, number, or parentheses. Ignore the character. So when I say ignore, was there a question?
We're adding it to the output.
Yep. Yeah. So yeah, we are going to want to add it to balance string. So I guess ignore might be the wrong word here. Let's just say add the character. If we get a parens, so we get a parentheses, we're going to have to do some further investigation. So there are a few cases here also. If we encounter an opening parentheses, it may or may not have a closing parentheses buddy. We're not sure at the point where we're investigating one particular character. Again, the future is unknown in terms of this loop. We're going to have to find out if we have a matching buddy. So if we have a parens, I guess let's break this down further. So we have 2 cases. We have opening parentheses and closing parentheses. If we have an opening parens, then we may have a closing buddy. If we get a closing parentheses, check if there was a buddy. So when I say buddy, I just mean appropriate closing and opening pair. So hopefully that terminology is cool with you guys. All right, so 2 cases, I guess, with parentheses. If we get a closing parentheses, we should have a history. So we should be keeping track of some history of like, hey, like we have 3 opening parentheses that we found. So if we find a closing one, we need to, I guess, pair that up with the most recent opening parentheses, right? So again, if we go back to our examples, where's a good case here? I guess here, in example, whatever number this is, we have 2 opening parentheses at this point, and then we get a closing one. So this closing one pairs with the most recent opening one, right? This parentheses is not going to close, the one that was first in the list. It's the most recent one. So that's kind of how we could pair them off. So in that case, if we do have an extra, we know which one is the extra one. All right, so if we get a closing parentheses, check if there was a buddy. Okay, I think this, for now, I think we have a good idea of what our approach might be. We might need more steps. Again, this might not be a complete pseudo-coded solution, but I think we have the general idea of what needs to be done, especially within our loop. So I'm going to start coding that up. So I'm going to loop through our entire string. So let's do that. For loop seems to make sense. So let's do a for character in my string. All right, so if we get, let's say if this is not equal to opening, all right, so this is, if it's not a parentheses, either opening or closing, we want to add that to our balance string. So that's our output. So let's do plus equals C. Again, C is just my character in the string that I'm currently investigating. All right, if we get, so that takes care of this. Let's put our comments in appropriate places here. All right, so that's, again, the easy case. Well, now we gotta tackle the parentheses case. So else, if C is equal to opening, what do we want to do here? So we may have a closing parentheses. So in this case, I'm thinking we're going to need to store this or track it somehow, right? So we could either have, a counter, as in the counter can count up if we get an opening parentheses and count down if we get a closing one. But that might not quite be the best because we're going to need to know when we don't want to insert it. So again, we're at a point right now where we have an opening parentheses that may or may not be part of our output. So we can't add it to our output right away necessarily because we might need to remove it later. And if we do that, we're going to need to keep track of it. So what's a good way we could do this?
Push it to an array.
Yep.
So we can keep track of where we found it.
Absolutely. Love that idea. So I'm going to call it opening parens list, and that'll just be an empty list to start off. And in this case, when we get an opening parentheses, I think it makes sense to add it to our list that we just created. So open parens list.
We may want to enumerate in our for loop because we need to know where we found that.
Yep, all great ideas. I think you're on the right track, Don. So yeah, we're gonna go through this probably a couple of times. So let's keep that in mind, what Don said. All right, so if we get an opening parentheses, we're gonna store it. And then if we get a closing one, we need to find if there's a buddy. So the buddy is gonna be in this list. If there's no buddy in there, then we know that it's an extraneous closing parentheses. So again, in that case, that'd be like if we investigated this parentheses, but found that our open parens list was empty, well then we definitely know this parentheses does not have a buddy because there's nothing before it, or no opening parentheses before it. So in this case, we just do an else because we cover all 3 cases, right? We have neither that or that, and we have this, we have this, and then else case will be closing parentheses. So if, let's do open parens. All right, so if our open parens list is 0, that means that there's nothing in it, then we know that we could just ignore this. So I guess in this case, we could do a continue. Again, continue is just going to go to the next iteration. Else, all right, so we have this open parens list. When we find a buddy, we will kind of want to cancel them out. So we found a closing parentheses. So let's just add a comment to make that clear. That's what we're doing here. We could even make this like an else if, just to make it like just in case, like let's say letters, let's say there's some other case. Probably should structure this a little differently, but I'm going to keep it as is. So this is, again, where we have a closing parentheses. we have two cases. If our open parens list is empty, that means this is an extra parentheses and we can just ignore it or get rid of it with regards to our output. Otherwise, if it's not empty, I think we need to pop off. All right, so pop's gonna remove the most recent parentheses that was added. All right, so this will be one less buddy to match up with for closing parentheses. Does that make sense to everybody? Any questions? Okay, so again, definitely need to test this out. So let's see, when we get...
Didn't we skip adding the valid parent to the output string?
Yep, that is correct. So again, we're adding our character. If it's not a parentheses, if it is a parentheses, we're going to need to add it in, I guess, the closing case. So if we find a buddy, we pop off the buddy, but then we want to add the closing parentheses. So that's going to be our character. And then, yeah, in the opening case, this is where it gets kind of tricky because we're going to want to add it if it has a buddy, but we don't know if it has a buddy at the current time we encounter it. So let's just add it and let's kind of talk about what we need to change going forward. So let's just, I feel like I have something that might work. I want to see where I'm at. Again, incremental testing is good to do. I don't want to write my entire algorithm. I probably got too deep into it before I actually did it. I probably should have printed out all the characters, kind of make sure I'm hitting my branches and my if statement correctly. So I probably got a little ahead of myself there, but let's quickly run this code and see where we're at. So I'm going to call balance parens, and let's get a good example. So I think this example looks pretty good. Copy that. Okay, so expected outputs, copy this entire thing. Should look something like this. I am returning my string, but I need to print it out. So let's grab that value. So let's say output from there, and I'll print this out to the terminal after calling my function. Okay, so let's give this a run, and let's see what our function is doing thus far. Maybe we get a correct solution. Maybe we get some incorrect items. Let's find out. So do Python balance parens.py. Okay, so this is my output. Let's compare that to what I expected. So, okay, this looks pretty good. I think that matches what I expected. Let's just kind of understand what our algorithm is doing. So I'm gonna take my input and kind of walk through my algorithm, and then let's kind of see what each part is doing. So our input is A, B, C with a bunch of parentheses. So this parentheses does have a buddy right here. So right after the B. This parentheses that before the C has a buddy right after the C. And then this parentheses has a buddy immediately after it. So we just have an extra closing parentheses. So if we went through our code, when we encounter this A, we hit this part of our branch, which means we just append that character because it's not a parentheses. We don't have to do any investigation. When we get an opening one, we append it right away. Oh, sorry. We append it to our list, keeping track of open parentheses, and then we also append it to our output. So anytime we get an open parentheses, we right away append it. Then we get to this B, again, same case, append it to our string. We get a closing parentheses. So let's go to our closing parentheses logic. So in this case, there's two possibilities. One is if our opening parentheses list is empty, we're going to continue, which just means go to the next iteration. We're not going to do anything special here. Or if our open parentheses list has an item in it, we want to remove it because that's the paired buddy. So we don't want to reuse the opening parentheses since we already matched it up with the closing parentheses. And then in that case, we want to append it to our output. So since we already had an opening parentheses, we know that our open parens list should have something in it. Therefore, our length will not be 0. So in that case, we'll append to our output string. So that gives us that part. Same thing happens with the parentheses C. We get an opening one, so we append it to our list. We get a C, which means we append it right away. And then we get a closing one, which matches up with the item. So we remove it from our list and then add it to our string. Same thing with this pair. Again, nothing too complicated. They're back to back, so it's pretty simple. And then we have this extraneous one. So this extraneous one, or this extra closing parentheses, is removed essentially by this continue because our output is balance string. So this continue says we're not adding it to our balance string. So that's kind of how it gets removed from our output. All right, so we're not actually adding it to our output and removing it. It's just we're ignoring it from appending it to our output. All right, so in this case, we got the correct output, but that's only one particular test case. Let's actually run another test case, and I happen to know what's missing my solution, but let's find a test case that exposes it. So let's go with this kind of awkward looking test case, all opening parentheses, right? So the output should be empty string because these are all unmatched opening parentheses. So let's give this a run. I'm gonna put that here. Looks like the output is empty string. I don't need this comment up here. Let's see what our current algorithm outputs. So I'm gonna do Python balance parens. All right, so I got all opening parentheses. That is in fact not balanced. I was expecting empty, but I got all opening. So that is a bit worrisome. So let's actually, again, kind of investigate what our algorithm's doing and find out what's missing here. So again, we have our input of open, 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 open. And VS Code is trying to be helpful by giving me close parentheses. Don't need that in this case. All right, so we have all these opening ones, right? So we go through our loop. We're never going to hit this case because we're always going to have an opening parentheses. So this is the case where we have a letter or number. So this is going to be never hit. We do hit this, and actually this is the only part of our if statement that we're hitting, is this else if we have an open parentheses, we want to append it to our opening parens list, and then we always want to append it to our output, right? And then we never hit this part of our else or of our if statement because we never have a closing parentheses, right? So going through this loop, all we're going to be doing is increasing our list with open parentheses and then appending our output also. So when we get out of our for loop, like when we're down to our return statement, we've just appended a bunch of opening strings here, but that's incorrect, right? We need to not have unbalanced parentheses. So these are all unbalanced because there's no closing buddies. So that's something we definitely need to figure out here. Okay, so let's think about this. So after we get through this for loop, we should have popped off every matching opening parentheses. So in this case, we know that we have, like, if we investigate open parens list here, this will have, let me comment this out. So this is what my array looks like, and a little difficult to parse. Basically, it's just 5 items that are all open parentheses characters. So I know at this point in my algorithm, I know that I have 5 unmatched or unbalanced opening parentheses. The question is, how can I actually go about removing them, right? So if I want to jazz up my example again a little bit, let's actually make this a little more complicated. So let's say I have opening and closing in the middle. All right, so these parentheses that are surrounding B, those are balanced. So in this case, I have a total of 6 opening parentheses. 5 of them are unbalanced, but this one is good because it has a buddy that closes it. So I can't simply go through my string and say, just remove the first 5, or I can't say remove the last 5 because I don't necessarily know which ones are balanced and which ones are unbalanced, right? So it gets a little tricky there. I think Don had a good suggestion of keeping track of the index that we're finding the open parentheses at. And that is a great suggestion because, again, as I noted, I can't just simply say, okay, I have 5 unmatched opening parentheses. Let me just take out a random 5 or the first 5 or last 5. Like, it's going to be specific open parentheses that I need to remove, not just any open parentheses that I may find. Okay, so this list is good, but it's not good enough. I need to keep more data in here. So I'm going to actually change my list to say, let's see, open parens and name it index. So I tend to name my variables pretty descriptively, so they get kind of long. I just like having that description, so I exactly know what it's keeping track of. So open parens index list. So instead of keeping track of just an open parenthesis character, which doesn't give us much information, I'm going to keep track of the index at which I found that open parentheses. All right. So in this case, I'm going to need to keep track of index. So I'm going to do enumerate. Let's spell that correctly. I think that should work for a string. If not, we'll have to change it. Okay, and so
MER.
Thank you. So I have this I value. This I is going to be the index in our current string that we're investigating, and then the C value is the actual character, so the value at that index that we have. So now that I have this index value, I'm going to append that to my list instead of character. So I rename my list. I probably should rename my use cases. So I have one. Probably should do a find and replace, but in this case, I'll just do it manually. All right, so I append that index. So that index, the existence of that index still tells me that I have an open parenthesis that needs a buddy. So it doesn't really matter what I store in here. Anything I append, that just denotes that I have an open parentheses. Okay, so I append that index here. Let's add some comments to make that clear. So append index of open parentheses. All right, so then going down to our closing case, and we can pop off those values. So that's the same thing. Again, we found a buddy, so we want to remove the opening parentheses buddies to cancel those out. We still want to append the closing case. In this case, we still want to append to our balance string, but we may not need it in our final output. So this is where it gets maybe a little confusing, but I'm going to actually create a new string. So you might be wondering hey, why are you just creating a bunch of variables? Could make this more efficient. Again, we do have 2 strings already that we can kind of reuse, but I'm going to create a brand new string. So let's call it fully balanced string. All right, so fully balanced string is going to be my final output. Sorry. So for this case, again, I'm going to want to go through if there's anything left in my open parens index list, I want to ignore or basically not add those to my output. So I'm going to go through that list. Let's say all right, we got to make sure we do this correctly. So,
Hey, Ankur.
Yep.
When you're storing the index of the open parentheses, don't you want to store it in balanced string, because the index in your original string will not be the same as the index in balanced string because you'll have removed elements. So the open parentheses might not be in the same place in balanced string.
Absolutely. That's a great observation. That's something I was just going to mention. We got to make sure that we know what this index value is. So currently, this index value is mapped to this initial string, right? And as Sean mentioned, the reason we can get out of sync is because of this case right here, where we drop closing parentheses that haven't been matched yet. At that point, we're kind of getting out of sync with str, which is our input, because we're going to have fewer indices that might impact, again, this index that we're storing, that's not going to map exactly if we drop off some characters. So that's a good point. We want to use the index for balanced string, not string itself. So how can we do that? So if we, instead, maybe we don't even need that index here. So we know the index of balanced string that we're appending to right now because we can just take the length, right? So instead of doing I, we could just do len balance parent or balanced string and then -1 because we're off by 1. So again, let's say I add a value to balanced string. If it's the first character, the index of that value is 0. So since I appended already, the length would be, sorry, not that, right. So basically I want to get the last item here and store that in my open parens list. So I'm mapping to balance string now instead of string. So this index value, I don't think I actually need it. Go back to that. So again, we're just getting the index of the last item that we just appended to our string. So we know that at this point, it's the very last item. So we store that. That should hopefully alleviate that issue that we're going to run into. So let's give that a try. So let's do for C and balance string. All right, so again, we want to investigate if that item exists in our index list. Then we want to not append it to our fully balanced string. The reason being is anything left over from this for loop, these are going to be extraneous or extra open parentheses that don't have a closing buggy. So in this case, we're going to check if, I guess in this case, we do know the index here. So I had my enumerate, I guess, on the wrong loop, because in this case, we want to investigate this index. So if I in open friends index list, so in this case, if this index is found in here, then we don't want to include it. So we'll do a continue. Otherwise, we want to append it to fully balanced string. Okay, we can rewrite this. We could do not in and then write this in the if statement. I guess personal preference. I could do it that way. One less line of code that way. So if I is not found in my open parens index list, then I want to append that character to my fully balanced string. Any questions? Obviously, we need to test this out. So let's.
Can you go through an example of what the open parenthesis index list is going to look like?
Absolutely, yeah, we could print that out. So let's keep printing it out as we append to it. So every time we append, let's say every time we pop, this might get kind of crazy, but hopefully we could manage it. And then let's say put a print here, leftover open. And I'm actually going to add an index back here just for our purposes. So enumerate that string again. And then I want to print out the I value over here. Okay, yeah, let's give this a run with some print statements so we kind of see what our parens index is looking like. And then maybe let's print out balance string also. Hopefully it's not too much output for us. All right, so print out I value, which is going to be the index of the string item. And then we print out balance string and open parens index. All right, let's give this a run and then investigate our output. So I'm going to clear my console, let's bring it up because I know I'm going to have a lot of output. Again, our input case, I changed a little bit, but basically there's going to be 5 unmatched parentheses, which are the last 3 and the first 2. So let's give this a run. Let's do Python. I guess I could go back. Okay, so we got a bunch of output. Let's actually match this up to our print statement. So the number that we're seeing here, this is the iteration we're on. So 0 means we're investigating the first character. So that's going to be this parentheses. 1 is going to be when we're on this parentheses and so forth. So looks like there's 10 total characters. If I count that, just make sure. 2, 3, 4, 5, 6, 7, 8, 9, 10. Yep, that makes sense. Again, we're 0 based, so just keep that in mind for any index. All right, so for the very first item, we get a print statement. We look at, this is what our balance string is currently, and this is what we appended to our index list. So for the first item, this is what balance string looks like, and then we store that in our index. So at index 0, we had an opening parentheses. Our next iteration, we append our balance string. So this is, again, an aggregate of what we're going to output, or I guess a temporary output. We have 2 open parentheses, which matches the 2 open here. And we have the index 0 and 1 in our list, because that's both of these parentheses. Third item is an A. So in that case, we just simply append it. We don't have to update our list, because that's on an opening parentheses or a closing parentheses. We get to this third opening parentheses at index 3. That's, again, we're just keep appending to our output for any opening case or non-parenthesis case, we always append. Our list now has 0, 1, and 3, which again is mapping the items here. We get to 4, which is a B, and then we get to 5, which is our new case. We get a closing parentheses. In that case, we have a buddy at index 3. So if we look at that, where is that? Right over 5, 6. Okay, so I guess I'm not printing out in that case. That is what happens. I'm printing there. All right, so I'm trying to make sense of my output here. So I got to here, then here. Oh, sorry. Okay, right here. So this is a closing parentheses case. Notice our balance string did not change because we had a closing parentheses that had a buddy. So we didn't add that closing parentheses in here yet, sorry. Okay, so 4 is the B.
It's because in the case of your closing parenthesis, you're not hitting the section of the loop where you have your print statements, I think.
So I hit this.
Oh, never mind.
Looking good. We left the right parentheses out of the output string, and we popped the 3 off the left parentheses.
Gotcha. I have this out of order. That was my issue. Sorry. I want to print after I update my string. Sorry about that. Let me quickly run that again. All right. So we were at this point. Sorry. So this is what I was looking for. So we got to our closing parentheses, and a couple things happened. We do append the closing parentheses here because we had a buddy, and then we update our list. So we popped off this 3 because again, the most recent opening parentheses is going to be the buddy for our current closing parentheses. So we leave our 0 and 1 in there because they're still unmatched. But this 3, this item at index 3, again looking at our input, this parentheses got a buddy, so we pop off from our list. So this list really should be named like unmatched opening parentheses, I guess, instead of just open parens. So let's just kind of mentally keep track of that name. So this is unmatched open parentheses. So since we found matching parentheses, we pop it off because this is no longer unmatched. So that's what happened.
It's actually not yet determined to be matched open parentheses. So
correct. Yeah. So it's TBD. Unmatched parentheses or not. Yeah, so they might be matched at some point, but I guess the current values in here are all unmatched at that point in time. So that's what that's keeping track of. So we pop that off and then we continue on. So then we get a couple extra unmatched parentheses, or I guess 3 extras. So those are what we store here. All right, so at the very end, leftover parentheses are 0, 1, 7, 8, and 9. So that is correct as far as I can tell, because this parentheses got a buddy, so we popped it out of our leftovers array or leftovers list. Okay, so that looks good to me. And then let's actually check our output here. So output, let's get rid of our print statements. I'll keep that one. Any questions? I want to make sure I'm not going too fast through this. But if we run this, we get our output of A, parentheses, B, and C. And let's manually validate that's what we should expect. So we have, those are unmatched. A is fine, so that should be in our output. That is matched by this guy. So we have A, open parentheses, B, and then again, this closing one is matched by this opening one. So that makes sense that both of those are in our output. And then we have a C. And then these 3, again, are unmatched. So it looks like that's what I would expect from my output. And that is what I got down here. So that looks good to me. Let's actually go back to our spec and add the remaining test cases. So I think I have something that looks pretty good here. I want to add all the test cases that we have and maybe any extra ones. So let's add those quickly. Test case 6 itself. Do some copy and pasting. All right, so this goes over here. Output should be this. Good to have a lot of test cases here. So we did that one. Let's do this one, which we kind of handled. Probably should add in our test case that we manually did since we jazzed it up a bit, but this should be empty.
What about a test case with all right parens?
That's a great idea. We should definitely have every possible circumstance. Let's do a bunch of those. Should be empty string. Let's just do the one we did. Again, we know it works, but Since we know it works, if we update our code going forward, we want to make sure that we didn't break anything. So we had A, B, I think whatever was have a bunch of extras. Should return A, B, and C. We actually move that C, just put it in the middle of somewhere. Still create the same output. Okay, so empty strings for both those cases. This should prune off these guys. What else? What else? Let's actually add that there. Okay, we have a couple more, so let's do this quickly. So we have a bunch of good test cases. Hopefully we pass all of them. Good to be thorough here. So did that one. Let's do this one quickly. Getting a good workout with my copy and paste buttons. So that's friends. That one should be double clothing. And finally this one. So I need to make sure I have unique test case names. So in that case, I duplicated them. Add some bad tabbing. Okay, so this test case goes there. And output should be triple parentheses. All right, cool. So we have 11 test cases. Let's see how we do with them. I'm going to get rid of these. All right, let's give our test suite a run. So to do that, we just got to run our spec file for unit test. And do Python balance parens spec, and I'm going to cross my fingers and see how I do. Okay, I did not pass all my test cases. So looks like, where's my output? So all these dots mean I passed. So I failed test case 8. That's not good, but that's why we have test cases. Let's see, was that the one I kind of ad-libbed here? Test case 8, all right. So in this case, I thought that should be my output, but it looks like I did screw that up because these two are buddies and then these two are buddies. So this is the extra one. So that is a bad test case.
I think you have two test case 8.
Oh, I do. That is also a problem. Thank you, Musa. Yeah, so unique test case names, always good to have. Otherwise, you're not going to know which test case you're actually filling. So it looks like I have 12 test cases. Sure. Yeah, thanks, Musa. That was definitely important. So, okay, that was a bad test case on my part. I lazily did this. So I thought this one would match this guy, but it looks like this guy is matching that guy. So output should be that. That's always good to make sure you have accurate test cases. That is very important. On that. Okay, it looks like I passed all of them. I got some extraneous output just because I was printing out some stuff for my algorithm here. So let me just comment those out. This, let's see. Okay, that does not need to be here. All right, so it looks like I'm passing all my test cases, a dozen of them. So again, I think we're pretty thorough there. I think we covered pretty much every case where sometimes we have empty string. I guess one thing we could test is straight up empty string. That might be kind of a simple test case, but why not? Just in case our algorithm does something weird in that case. So if we pass in nothing, we should expect nothing. Simple enough. Yep, okay. All right, so we're done. We accomplished our task. But again, I always kind of challenge myself, and I want to challenge you guys. Go back to your code and see if you can improve it in terms of either making it easier to read, but also the main thing is, can you optimize it either like not necessarily redoing the whole algorithm, but kind of just making sure that you don't do extra work when you don't need to. So I do know that there's some extra work that I am potentially doing. So one case might be down here. So if I don't have any leftover items, I don't need to do this, right? This is going to be wasted effort, as I'm going to iterate over my entire balanced string, I'm never going to hit the, like, I'm always going to append my character. Again, this is in the event where I have nothing in my open friends list. So in that case, it might make sense to just not do this part of my loop, because again, that's extra work that I know doesn't need to be done. So a couple ways to alleviate that, I could just simply do a if, if len of that list, that equals 0 right here, then I know, hey, I have no more work to done. I rematched all my opening parentheses with closing parentheses, and I chopped off all the extra closing ones if there were any. So in this case, I could just return balance string. Balance parens? No. What do I call it? Balance string. All right. So hopefully that makes sense. Again, this is a simple 2 lines of code, but that definitely adds optimization in that you avoid doing another for loop over your entire string. So imagine if the string had like 1,000 characters in it, right? The balance string, like you're going to do that iteration like 1,000 extra loops for no reason at all. And again, we might think, okay, computers are fast, like it doesn't really matter. But again, when your data size gets really large, so imagine this balance string is like the entire, I don't know, what's the largest book out there? I don't even know what a large book would be, but like, let's say it's your entire Harry Potter, all volumes of Harry Potter, like that's what your string is. That's going to be sizable, right? I can't even estimate how many lines that is. Let's quickly look that up. Anyone know offhand? How many characters? I can't say characters. How many letters does Harry Potter books? I don't know if there's going to be an easy way to find this. Okay, there is.
It's approximately 1 million words.
There's 1 million words. Okay, so I don't know what the average word length is. Let's say 5 characters per word. So let's say 5 million, characters we're going to go through. That's going to be noticeable in your algorithm here. Again, it might not be like super long. It might not be an hour, but 5 million iterations is going to at least take a few extra seconds. So in that case, if I can avoid this, then I totally should, right? So this to me makes sense. Let's make sure we're clear on this with a comment. So if there are no unmatched open friends, all right, so again, simple optimization, didn't take too much effort on our part, but that definitely improves our algorithm. What else can we do? So if we had like an empty string that was passed in, like that was one of our test cases, I don't think we could check that right up front. Like we just do, if str, if str is empty string, we make a return. We probably don't want to do a find parentheses, because that's doing a find is actually, I can just return string. I don't know. So one, you might be tempted to say, hey, why don't we search our string and see if we find any parentheses in the first place? And if there's no parentheses in there, then we know that the input is going to match the output, right? That might be tempting, but doing that find is essentially doing a for loop anyway. It's not a magic, like the find method, and this goes back to reading documentation and understanding what the methods do. Doing a find on a string is essentially, again, the find method is going to iterate through the string and try to grab the items you're looking for. So that find is essentially a for loop anyway. So it's actually going to make your algorithm less efficient if you do that find and try to return early, because you're going to have to do this for loop in the case that you do find a parentheses. So you're going to do that for loop twice, essentially. So in that case, I would not want to do that optimization. What else? Any other thoughts of how we could optimize this? I think we can definitely make this a bit easier to read. So I'm actually going to swap around some of this code because I wasn't happy with it. So I'm going to actually make my if statement that. Else statement will actually check for this. So this is going to actually check for opening and closing specifically. And if neither of these are hit, then I can just do my else case, which is the letter case. Again, for me, I feel like this makes more sense because I want to check my particular cases first, and else should be every other leftover case. I guess the more common case. So else will be there. All right. I think that makes my code a little easier to read. I could actually swap this. So if I want to do, if this is greater than 0, I can just do this. So that gets rid of an else case. So now if I hit this if statement, we'll do it. If I don't, then basically I'll not do anything else. So maybe I'll have an else continue. Why not? I don't necessarily need this continue here because there's nothing being done down here. But if I did add logic here, like if I added logic here, then this continue kind of protects me from doing this logic, assuming I don't want to do that in the case where I don't append this. All right, I do have some duplicate work, as in all 3 branches for the most part are appending. So I can maybe try to alleviate that. The only problem is I need to append my list item here. We could get smart about that. So again, I'm not sure if this is technically making my code better, but I'm trying to reduce redundancy. So in this case, I'll append here. I'll get rid of my else case. All right, so we always want to append if we get a letter, and if we get a letter, number, or opening runs. All right, so we always append those cases. Only time we don't append is this continue case. So I can get rid of this. Again, I updated my index. Instead of that -1, I'm just grabbing a length of balance string because I'm appending after instead of before. So again, that's maybe a bit questionable because this is relying on something that's going to happen in the future, which is down here. But I think I'm okay with it. All right, so opening parentheses, we just append to our list, which is the size of our string, because that's going to be the index of the character we append. In this case, we pop. This continue now will avoid our appending. So again, I condense my code, so I have a single spot where I'm appending to my balance string. So I think that's generally better in terms of code design, because in case I want to change like my appending thing, like let's say I need to shift my character. If you guys did the Caesar Caesar cipher challenge from yesterday, that's something that you're doing where you're shifting characters. So again, that could be something that gets added to our challenge. Who knows? So okay, so I did some restructuring. So I think my code is a little better, easier to read. There's less lines of code. I have comments here, so hopefully that it's pretty easy to understand. I added an optimization here, so I don't do extra work. Okay, so again, we had a working solution, but now we improved it. But now that we made changes, we need to run our test cases again to make sure we didn't break anything, right? That's kind of the whole point of test cases, so that we could safely refactor our code without changing our algorithm output. All right, I ran my test spec. Good, I still get 13 dots here, so it looks like the changes I made, for the most part, shouldn't have changed my algorithm. Again, might want to add more test cases just in case, but I think we're good here. All right, any questions on balance parentheses?
I have a comment. If we've got a program that's readable and running and working properly, and we know it's only going to be used on 1 haiku a day, then does it make sense to not refactor it because we'd be spending more time and potentially introducing error?
Sorry, so if the question was for these challenges, as you guys are going through them, if you guys get to a working solution, Don, correct me if I'm missing your question, but the question is, should you guys be spending the time to kind of going back through it, refactoring in terms of optimizing or removing redundancies or just cleaning up your code? I would say yes and no. I would say it's not a priority, but it's a habit I want all of you guys to get to at some point, where anytime you get something working, you should always have that mindset of how can I make this better? Now, is it worth your time to do that for all these challenges? I can't answer that, but I want you guys to still have that mindset of, hey, I wrote this code. Even if you don't want to make the changes, have some idea of like, okay, I might need to change anything around or maybe re-implement part of my algorithm to make it better. Maybe don't go through doing it for all the challenges, but I think it is worthwhile going through it. Again, the way we go through it is have these test cases so that when you have a working solution, you can refactor it safely and then still run your test cases to make sure you haven't broken anything. So Don, to answer your question, I'll give you a yes and no. I'd say yes, I would highly encourage that you guys are mindful of how to improve your code, whether it be readability or optimizations or various other ways we can improve our code. But you guys are your own time managers. So if you think it's worthwhile, go for it. If you're trying to balance, hey, I have 7 challenges today, I'm on my 3rd one. Do I want to spend all this time refactoring my 3rd one or moving on to the next ones? Probably better to tackle those extra challenges, but again, up to you guys. So great question. My response would be just be mindful of improving your code always, even if you don't go through doing it.
No, I was actually thinking more in terms of real life where
Oh.
somebody's paying you to get something done. Do they want to pay you an extra few hours to make it faster if it's already readable and running right and performing, and you know it's not going to be used all that much?
Great question. So that, I mean, part of it will come down to what your client wants. So if your client's like, hey, I don't care how it executes, I don't care how slow it is, just give me something that works right away. Like if their main concern is getting a product delivered as soon as possible, then yeah, then you wouldn't be doing that. But generally speaking, if that isn't your time, if that isn't your constraint, as in your, your client isn't saying ASAP, I think it's always worthwhile because you never know when you're gonna tackle your code. Either your client might ask for new features, or you might just want to look at your code in the future. It's always good to have something that's written properly. Either you or someone else might be reading it in the future. So always good putting in that extra effort of cleaning it up. As like any project you do, let's say you're doing a home renovation project. Sure, you want to like remodel your bathroom, but you want to make sure you do it right, and you have like you put the extra time and effort to make sure all the tiles are aligned properly, everything kind of looks and functions properly, if possible.
In my question, readability was my first requirement because that's always a thing. If it and it's not readable for other people, when I return to this thing in 9 months, I won't remember what I did.
Exactly. Yeah. Readability. These are steps of becoming again that better developer. So this is something again I'm going to highlight in today's slides, and probably you'll see probably 3 or 4 more times. There's 2 parts to being a good software developer. One is being able to solve a problem, and then part 2 is that thing that differentiates you between just people that can solve problems and that can do it really well. And that doing it well is again writing really good code, easy readability, following naming conventions, using proper architecture, optimizing for memory and speed. Like again, there's so many facets to making code better. So that is something I again will encourage all of you guys to get better at as we get further into the program. All right, so I'm just committing my code. So I did a git add, git commit with a nice comment, did a git push origin. So that should be pushed up to my balanced parentheses. And refresh this. All right, my Python solution was updated. I did not do my JavaScript solution. The algorithm is going to look essentially the same. So there's nothing going to be too exciting there. I'm going to just do a quick pull request. So let's go back to pull requests, new pull requests. And okay, just want to, scan the files, make sure I have everything I want. I do have some print statements here that are commented out. I probably should have gotten rid of those. Not the end of the world, but that kind of, definitely doesn't mean I have the cleanest code possible because these are kind of extraneous. But for the most part, I'm happy with my solution. I'm going to create a pull request and add in hopefully I swallowed that correctly. Create pull requests.
That's probably why somebody called it brackets. They didn't know how to spell parentheses.
That's probably, yeah, I make typos all the time. So definitely want that consistent. So make sure we do that next go around. All right, I'm going to stop the recording here.